Okay, today I would like to talk about a little discussed subject in programming, which is errors. I made a quick poll: who pushed the bugs in production? Oh, there's a lot of liars here. So even you are a whole superhero, and if you say that, I think you're a liar or you need some psychiatry. Okay, now, shit happens, error happens, and most of the time, we don't care. It's okay, because programming languages implement lots of tools, utility, and programmers implement a lot of tools, utility too, to mitigate and manage these errors. But sometimes you have really to take care about them. Otherwise, oh shit, this is a $500 million lost in flame because of uncoded floating point exception. This is a famous case of the Ariane 5 inaugural flight in 1996. There's also some other example of very big disaster in programming. This one is famous. Do you know the Terac 25 case? This is an error case that caused death. 3 patients are died because of an error in a programmer. So what do we care? What do I care? In fact, this talk is really inspired by some talk I've seen before. The first one is Rethinking Errors by Bruce Haskell at PyCon. I can cite also the talk of Brandon Rhodes that we saw today, and he gave the same talk at the PyCon last year. And it's deeply inspired by real-world example. My own example in my company, and some example at some other talks I've seen. I've seen a talk at RuPy given by Tarek Ziadeh, who works at Mozilla. And he developed a tool called Vorien to manage a big outage at Mozilla. I will talk about that later. And finally, to err is human. So this mantra is well known, but you may not know the second part of the sentence, which is perseverare diabolicum. So today we try to not persist in errors. There's a clear antagonism between the fact that we are humans and we're making mistakes and the fact that everybody wants error-proof software. I will argue that bad error handling produces bad programs, and that hopefully language implements systems to manage these errors. I will give you a sightseeing of how helpful they can be. But where does happen errors? I don't know if you know this PEPCAC, the problem existing between keyboard and chairs. In fact, this is the main issue, the main problem. And errors are a chain of responsibility because we are developing stuff on existing libraries, on existing systems, and we're delivering this stuff, these new libraries, to another people, which can be users or developers, and we can use our library. And there's a great chance that we produce a new set of errors when we're working on the construction of a new library. Before going further, I would like to say some words about me. I'm Olivier. This is my Twitter account. You will have the link to this slide after this talk. And I'm the lead engineer at TinyCluse. TinyCluse is a French startup, and we are building a predictive analytics SaaS platform. So we're dealing every day with billions of events that come from our clients, and we are making predictive analytics on this data. One thing that we've learned at TinyCluse is that computation is valuable. When you're starting a computation that may take hours, you don't want to lose every result because you have one exception somewhere. So to talk about, specifically about errors and way of manage errors. There are three main way of managing errors. You may all know at least two of them, which are return codes, exceptions, and monadic error control. Every language has at least two of them. In fact, there is two family of error control, because exceptions are a feature of a programming language, and return code and monadic error control can be implemented in mostly every programming language. To speak about return code, get back in time and talking about C. C has no exception, and errors are managed either by return codes or the Hervieu special register. Well, there are also some mechanisms like the goto and non-local goto with set jump, but I think it's out of scope. So the good about return codes, what are return codes? Return codes are the special value returned by a function. I have no code sample because I think it's obvious. The good is they are easy to implement. The bad, they can be easily ignored. They are not universal. For instance, operators and constructors, like in C++, can't return a return code. And the most embarrassing stuff about return codes is that they need to be translated. For instance, if you're using curl and you're looking at the list of error codes that can be written by curl, you have a manual to read. And I would say that developers rely on conventions. A lot of us say documentation, but what disturbs me as a lazy programmer is I do not want to read a man page or documentation to know if a method will return an error or not, and what is the nature of this error, and what is the set of values that can take this error. So safely managing errors returned by each function is painful, and for me, it's like the mantra, read the fucking manual. So C has another stuff to manage errors, which is Hervieu. I put here an extract of the C99 reference, and you see that even the committee is not really agree about the fact that Hervieu is a good idea. They criticize its implementation here, but the usage of Hervieu is also awful. For instance, I will take two C code here, and maybe the left one looks good, but Hervieu should be visited manually. So no, it's not good. You should set Hervieu to 0 before using it, and etc., etc. You have methods in C, like fopen, qui may set Hervieu even if no error has occurred. So you have to check the return code of fopen, and if it's null, it's because an error happened, and then you have to check the value of Hervieu. And there is much more function like that. You have set local, signal, etc., etc. In each of them, you have to check the value of Hervieu and check the value returned by the method. It's worst, in fact. And once again, you have to read the man page of each method to safely know what happened. And yeah, it's like that. You would just want to use a function. It seems obvious, and it's not. Last thing is some methods could return a code that is not really an error, but is more a status than an error. We all use this kind of method. I will say more later about that. Return code in Go. Initially, there was no exception in Go, and you have to manage your error with return code. Here, I put the example of the open method in the OS module. And you see that in the signature of your method, the method will return a file descriptor, file, and an error code. And in Go, you will have to, if you want to grab your file descriptor, say f, comma r, and then open your file. And your compiler will be very clear if you try to do nothing with r. It will say, hey, you've declared r and you use it anywhere. Use it, please. So for me, it's a win because it enforces you that you need to use the r that is returned by the method, and the signature of the method indicates that you will have a return code that may indicate an error. Just a quick word. This method does not return a tuple. There is no tuple in a Go. It returns two returns value. It's not really the same thing. Let's switch to exception. In the creator of C++, I'm sorry, I don't know how to say correctly his name, so I will say the creator of C++. Cites in his book about the creation of C++ a citation of Jim Mitchell, which says basically that resumption is seductive but not valid. And it is admitted that exception should be used in exceptional cases. And yes, this is a truism. If I make a quick summary of exception, they are great when everything goes wrong, because there's a quick way to stop your program and give you tremendous insight of what's happened. Sadly, they do not cross the process boundaries easily. So it's not a universal solution to stop the whole computation if you're doing a computation in parallel. In some languages, when you raise an exception, you should take off your memory. And I have no opinion on the last bullet point, but exceptions are typed, and catching all of them leads to many catch except blocks. Often, I see people that complain about that. In Go, which introduced exception, they change the wording that we usually see. Instead of using the word throw or raise, they use panic. And to resume an exception, they use the word resume. I think that these terms are more carefully chosen than the one we use in Python or in Ruby or in other languages. I would like to make an everyday comparison. When your house is in fire, okay, you're allowed to panic and to go away, to run, because your house is in fire. But when your dog pees on your carpet, you do not need to panic to resume the situation. So in one case, maybe you want to raise an exception, and in the other, maybe the exception is not the good pattern. But we're here at RuPy, which is a construction between Ruby and Python, and our exceptions are really exceptional. Dynamic languages love exceptions, and particularly Python. I don't know very well Ruby, but in Python it's sure. In Python, end of iterations is indicated by an exception, but not end of file. Okay. And novice and non-novice programmers abuse this language feature. It is for me my favorite pattern, which is the Pokemon exception. Okay, Gotaga Jamal. So you have a bunch of code, and maybe it raise. You take anything it raise, and I don't care. Well, actually, this code is taken in the OpenStack project. It's a cleanup script, nothing really, strategic, and but if you want to use, if you add really to use this try except block with paths, please use a context manager and log the exception. Log it at least, please. So, for a quick summary for an exception versus return code. Knowing what kind of exception will be raised is difficult most of the time. You have to read the documentation as for return code. And even if you know what this method could raise, because you read carefully the documentation, subcall method can also raise exceptions that are not described in the method documentation you have already read. So there's some trap. And as a plus, if you want to use function composition extensively, exception is better than written code. I say that it's hard to know exceptions that will be raised in each method. Java introduced CheckInception to solve this issue. I'm not a Java expert, but if someone knows why CheckInception are not widely used, is welcome to say an explanation. Back to the real world. Does anybody knows what is the behavior of socket.send in Python? Raise your hand if you're sure of the behavior of socket.send in Python. Only one person. Okay. This is the documentation of the socket.send method in Python 3.3. And I've outlined in bold methods that lots of us may not have read. Socket.send returns the number of bytes sent. Okay. Applications are responsible for checking that data has been sent. So you always have to check the return code of socket.send because maybe socket.send does not send your message. Another socket pattern should be while total bytes send, blah, blah, blah. But what happens if my socket is closed? Does the documentation help me? Not really. In fact, if my socket is closed, I have the socket.error that is raised. Well, okay, I can guess that if the socket is closed, I will have an exception, maybe. But what happens if total bytes sent stall? Each time I try to send data over my socket, I have no data that is sent. I don't know. It's not defined. So help yourself. By digging hollow, because Google code search is down, it's easy to find code that does not check the return value of socket.send. But thankfully, it's also easy to find code that checks this value. As a lesson learned, use socket.send all. Will be easier. Let's back to monad. So a monad is a monoid in the category of endofactors. What's the problem? It's gibberish. So some definition to try to understand monads. I hope there is no functional programmer nuts in the room because, oh shit. I'm dead at the end of this talk. Okay, so you have the definition of a high-order function. A high-order function is a function that does at least one of the following. It takes one or more function as input, and it can or it can output a function. Then you have the functor definition. A functor is a type constructor that obeys to composition and identity. If you want to have a raw view of a functor, think of the method map in Python. Monads. Monads are essentially a functor with two extra methods: method of join of this type and method unit. Roughly, if you want to understand join, imagine that you have a list of lists and it returns a list, in fact. Okay, brace. Yeah, drink some water. So, monadic error control. In Haskell, there is two types, mainly two types. There are maybe or either. In Scala, you have option, either, try, and some other one. As a disclaimer, when I arrived this morning at RuPy, the following slide was in Haskell. But I said to myself, well, Haskell is a bit cryptic, so I rewrote on my slide in Scala, and I begin Scala this at noon, so be fair. So, a classical use case, a div by zero. Oh, okay, so you have a method and you can't divide by zero. This is not new. And the differences between what could be seen in Python, if you try to divide by zero, we will raise an exception. Here, if your divisor is zero, you will return none, else sum. And none and sum are of type option. Then you can use map over a list. When you're using this map, we'll have the same result as before for one value, but here you have a list of options. We'll have some valid value when the divisor is not zero, as some invalid value which equals to none. After, if you use flat map that has a special behavior in Scala with list, you have filtered all of your values that was known. Remind you the LSST talks of this morning. You are a scientist and you have hundreds of petabytes to crunch. You do not want to, because you have an exception elsewhere, to raise an exception. You want to have all your results, and for function who has failed, you want to have valuable data, even by logging or shipped directly into the result. This is maybe the use case of either. This is the same use case. You have the method divide, and if you divide by zero, you will return a structure which is left, a type which is left, and a type right. I guess right because it's right, and left because it's not right. Okay. So you have the same output as before, mostly. And after that, you can use composition. And your second method, you want to call twice the divide method, and you want to add the result. Okay. I have written 3 times the add method, and each implementation is equivalent. But maybe the first one is the one that could be implemented by somebody that is used to program in Python, maybe. And the second and the third one use more functional paradigm. Okay? So it will output the result, or if it can't output the result, it will return the first error encountered. Here, my method divide, which is here, is not really helpful. In the left constructor, I don't say a lot of information, but I can pass whatever I want. And so I will have here, in this case, left can divide by 0. I will have any insightful information. The advantages is that its composition is easy allowed by monads. And you can filter or preserve your errors without raising exception along all your treatment. Can it be implemented in Python? Functional programmer nuts will say no, because Python is not a functional language, and it does not implement type constructor as in Haskell or Scala. But it's all about plumbing, in fact. Monad are nothing else than another design pattern. This implementation of either in Python is taken from the speech of Haskell in Python. I do not invent that. And you have almost the same behavior as before. Or I forget the result, but you can try to run this code if you want. To summarize, I will expose you my rule of thumb. Exceptions signals unexpected failures. So you should throw an exception only when you encounter an unexpected failure. If a method potentially returns an error, use an error code. And if you need composition around this method, then use monadic error control. My observation is it's fine to disagree with these rules. But please, in your library, please consistent in your own way of managing errors. Don't use mixing exception in some model and return codes in other. It does not work. And linters are sometimes more helpful when using return codes than exception. If you it's like in Go, in fact. If you type r equal equals and some method call, it's easier. Because if you do not treat your return code, your linter will say, hey, r is not used. And this is the end of this talk. So I wish you an happy handling and a nice evening at RuPy.